Hey guys, welcome back. So we're finishing up activity 40 today, but we're looking at 40.2 mutually exclusive, and I'm going to kind of go through the collective problems that I assigned you in the last video. We're looking at 11 through 14. So in 11 is asking basically, hey, we have these events, and we want to know whether or not they're mutually exclusive, and I need to take a moment here to realize or to ask you to recognize what the idea of subjective is. Subjective means that your answer might not match mine, and that's okay. We have different experiences or different beliefs as far as what it's asking, okay? So I kind of said on number 11 it's subjective, and that's okay. And I'll kind of walk you through that as we go. So for 11A, it says, what's the idea of visiting Fire Island? We see a lighthouse and we see a mansion. So some of you might be, hey, I only do one thing in a day. I would feel pretty comfortable saying that's not mutually exclusive. You can theoretically see the lighthouse as you're going to visit the mansion. Okay. For B, it says, what's the is it possible to take a car to the shore and take a train to the shore? I would say those are mutually exclusive, but we would have to say at least not at the same time, right? Because maybe on Monday you took a car to the shore and on Tuesday you took a train to the shore. So it really depends on if we're taking time. You couldn't really do both at the same time. Again, that's why these are kind of tricky, and I'm not going to stress on 11. Please don't stress about number 11. It's English where it gets ugly. When we get back to the math, it goes kind of simple. For C, it says on a fishing trip that you would catch a bluefish, a sea bass, and a fluke. Now, maybe one of those is fresh, one of them saltwater. I don't know. I'm going to say that it's not mutually exclusive. I'm going to say you could catch multiple those different kinds of fish on the same fishing trip, but I don't fish, so maybe they're in different lakes. I don't know. If you know that and you know that you can't catch all three at the same time, then that's fine. You can say they're mutually exclusive. I don't know. For D, it says attend a baseball game and a football game on the same Saturday afternoon. Yeah, again, that's personal experience. I would say you can because I'm pretty sure I've actually done it. But maybe you're a one event person. Maybe you think, oh, well, the baseball game would take the whole afternoon, or the football game would take the whole afternoon. So you can't actually do both. Okay. So again, don't stress on 11. Just as long as you understand the idea of mutually exclusive is that they do not overlap. All right. Number 12. Number 12, we're using the information they gave us, and they want us to find certain things. The first number that they give us is the or, so you would simply add those together because they're mutually exclusive. The next number they ask for is not A, so you would do 1 minus the 0.67 that was A, that would give you that. The next one is not B, that's 0.72 because B is 0.28, and so you would do 1 minus 0.28. The next one is not A or B, so that is how much is kind of in the outside there. That's the marking on the Venn diagram that's not there. It's 0.05. And the last one is kind of the definition of mutually exclusive. What is the overlap? What is the and? And so what's the probability of A and B? And that is 0 because they have nothing in common. All right, 13. 13 is pretty straightforward. We're talking about freshmen versus seniors. You can't actually be both, and let me clarify. I realize you could be a senior in high school and a freshman in college. We're talking more about 9th grader versus 12th grader. You can't be both at the same time. So we would simply add those two percentages together, 26.3 plus 22.8, and you get 49.1% chance that you would get a freshman or a senior drawing a student random from that school. Number 14 is kind of interesting. We're talking about visiting a lighthouse and the seasons in which that would happen. They tell you that in the summer, 75% of their visitors come, and in the fall, 10% of their visitors come. And then they ask you, what are the odds, picking at random a visitor from the visitor log, that they would have visited in the fall or the spring. In the fall or the spring, and be careful there. Notice they don't say fall or summer. So what we need to do is we need to fill out the rest of this Venn diagram. And this is a good one to see because notice we have 4 separate mutually exclusive events. It doesn't always just have to be 2. It doesn't have to be 3. It doesn't have to be 4. It could be as many as we want. So 0% of the visitors in the winter. Why? Because they're closed. It says so in the paragraph. And so the spring is the leftover. So think about it. Theoretically, every single visitor would be in one of these 4 seasons. So there is no extra. So we've got 0.75. We've got 0.10. That's 0.85. This has to be 0.15 because all of these together would equal the whole year, okay? And then so if they want to know, because these are mutually exclusive, if they want to know the odds that we would get somebody in the fall or in the spring, we would add these two together. So 0.1 plus 0.15, and we get 0.25. So probability that we would get a visitor in the fall or in the spring. And I wrote out spring because summer and spring start with the same letter. So fall or the spring, you're going to get 0.25. Hopefully that makes sense, guys. Let me go ahead and give you your homework assignment for this section. You're going to go to page 591, and you're going to do questions number 1, 4, 5, 9, and 10. Okay? As always, you can do all the questions if you want, but those are the ones that we think would help you the most and give you the most success on the upcoming test. All right? If you have any questions, guys, make sure you send me an email. It's Coach Williams or james.williams@fwbisd, and I wish you luck.